Let's look at a second example using these formulas for waves. The graph of an electromagnetic wave produced by a transformer is shown below. What is the wavelength of this radiation if its speed is 3 times 10 to the 8 meters per second? Well, we just finished talking about this in example 1, that this is some form of light. We have the velocity of light on our data sheet. Now, what else do we have to know? We want to know wavelength. So if we want to know wavelength, we need to know frequency. Now, I don't see frequency given in this question, but they do give me a graph, and they give me a time for different points on the graph. Well, since period represents the time for one complete wavelength, have a look at one complete wavelength. That's a complete up and down and back to where you start. So this is one wavelength from here to here. Whether you look at the up and down or you look at the wavelength that's going into and out of the page, it is the same length. So the time for one wavelength, in this case, using our graph, will be 10.0, also times 10 to the negative 6. So it's 10 times 10 to the negative 6 seconds. So we're using a graph to interpret some value for us in this question. Well, if I know the period, I then know I can use Formula 1. Period equals 1 over F. And I also know that I can manipulate this like I did in the last example. Frequency equals 1 over the period. I also have a second formula that has velocity equal to frequency times wavelength. So what I can do is I can substitute equation 1 into equation 2 so that I end up looking like this. Velocity equals to wavelength over period, because frequency equals 1 over t, so it's 1 over t times wavelength. And now if I wanted to manipulate this for what the question's looking for, equation 2 then becomes wavelength equals velocity times period. So I did this one as one single formula where I took a couple of these two simpler types of formulas and put them together, looked for the information that I was given. I was given the speed, I was given from the graph the period. This is how I could determine wavelength from that and do one single calculation. 3.00 times 10 to the 8 meters per second times 10 times 10 to the negative 6 seconds should give me a wavelength of 3.00 times 10 to the 3 meters in this case.